The new chapter for the session is surface areas and volumes. What is the surface area and what is the volume? Now that we have discussed about area and perimeter in a solid closed figure, similarly we have the concept of surface area and volume, which mainly comes in the three-dimensional zone. So let's see in brief about surface areas and volumes of different solid figures. For example, if I have a different sheet of papers, say for example I have this paper which is rectangular, we know that this sheet of paper, when just understood, is understood as a rectangle with length and breadth. But what if I start adding another papers, like I had the set of papers joined together? So when the set of papers are joined together, then it seems to form a solid figure. So this kind of a solid figure, which is formed by each sheet of paper combined together to form a bundle of papers, is what makes us enter into the concept of surface areas and volumes. Similarly, if I take the example of this is a rectangular plank. This is length and this is breadth, but this is the length and this is the width, and also we see that it has slight thickness on the rim. So if we take into consideration even the three-dimensional thickness along with the length and width, such a concept makes us introduce or enter into the zone of surface area and volume. For a solid object, we also take into account the thickness, and this makes us understand why surface area and volume come into existence. So let's recap with area. As we have seen that area is this total region occupied by the closed figure. So this is the area of this face, but this being a solid object has areas in all the different directions. It has area here and here and here and here and here and here. So totally there are 6 different faces for this shape, which is called a cuboid in mathematics. So when it comes to a cuboid, let's draw a cuboid and just understand the concept. Here is the cuboid, assumed to be seen from this angle. Now there are totally 6 faces: face 1, face 2, face 3, 4, 5 and 6 down. So each of the faces have their own area, assumed to be a rectangle. So surface area is the area of each face of the solid figure. So we understand the surface area is defined as the area occupied by each face of the solid figure. So the surface area is defined as the area occupied by each face of the solid figure. So in this case, there are 6 faces which occupy 6 different areas. So when you add up all the 6 different areas together, then the total area is called the surface area of that object. In this case, it's a cuboid. What is the volume? So in general sense, as I see this object to occupy some space, like for example, this object occupies some space. So any object in universe which occupies space is called the volume. It is the capacity, and hence let's define volume in terms of the capacity of this box is to occupy this much of space, and hence its volume is what it occupies in the space. So, in general terms, the volume is defined as the space occupied by the solid figure, or sometimes we also call the volume as capacity. So the volume is also called the capacity in some other means of understanding the volume. So here the volume is defined as the space occupied by the solid figure, and the surface area is defined as the area occupied by each face of the solid figure. So each face area when added up gives me surface area, and the space which the object occupies is defined to be the volume of the solid figure. Is how we understand the surface area and volumes of a three-dimensional object. Now that we have discussed about surface area and volume of a solid figure is understood through the different faces as taken into consideration. Now let's see how we can find the surface area of a cuboid. This session is about surface area of a cuboid. Cuboid surface area. So how do we find the surface area of the cuboid? Let's see in brief. Imagine I take a cuboid which is in the shape of a box. Here is a cuboid, and here I have said the length of the cuboid is this, and the width of the cuboid is this, and the height of the cuboid is this. If the length, width and the height are given to be L, B and H respectively, then the surface area of the cuboid is nothing but the area of each of the six faces 1, 2, 3, 4, 5 and 6. So top, bottom and all the round faces make the surface area. So for such cuboid which has all the faces covered, we have surface area of the cuboid is 2 times of LB plus BH plus LH unit square. That's how we define the surface area of the cuboid. So the surface area of the cuboid, which covers all the 6 faces with length, width and height, is given by 2 times LB plus BH plus LH, where L is length, B is width and H is height. Surface area of a cuboid given by the formula.